अब एक इम्पॉर्टेंट आर्टिकल है, मैकेनिकल फोर्स पर यूनिट एरिया एक्ट ऑन अ चार्ज्ड कंडक्टर and suppose this is conductor and charge on it distributed on its surface. Now each small charge repel to other charge, right? Therefore force of repulsion act on each element. Suppose this small element, suppose this is a small element of the conductor, charge on this is, suppose this amount of charge on this small element, then this small element repel its side, repel to other small element which also carry some charge. Therefore due to its own charge on the conductor, some repulsive force acts on the conductor, and total force on the surface of conductor is a vector sum of force acting on all small elements. Suppose on this small element df force act, for this small element df act, for this small element df act, for this small element df force act, then total force is summation of df. Charge provided to the conductor is distributed on its surface. A repulsive force act by the charge on rest part from the charge present at a small part of the conductor, and in this way force of repulsion act on each small element on the conductor, and the total force on the surface of conductor is a vector sum of force acting on the small elements, right? That is why charged conductor experience pressure outward the charged conducting surface. मतलब प्रेशर एक्ट होगा एक फोर्स पर यूनिट एरिया. अब इसको हम एक्सप्लेन करेंगे. लेट द सरफेस चार्ज डेंसिटी ऑन द सरफेस ऑफ कंडक्टर इज सिग्मा. वी विल कंसिडर पॉइंट आउटसाइड एंड इनसाइड द कंडक्टर, टू आइडेंटिकल पॉइंट P1 एंड P2. यहाँ पे हमने बॉडी दिखाई है, ये पूरा बॉडी है हमारा, ये कंडक्टर है बोलेंगे. अब इस कंडक्टर पे चार्ज दिया है, देखो ये पॉजिटिव चार्ज दिखाया हमने. ये कौन सा चार्ज है बोलो? पॉजिटिव चार्ज है. मतलब ये चार्ज और कंडक्टिंग बॉडी हो गया. अब आज हमको क्या करना है, स्मॉल एरिया ds पे कितना फोर्स एक्ट होता है वो निकालना है. तो इसलिए पहले मैं क्या किया, कंसिडर अ स्मॉल एलिमेंट ds ऑन द सरफेस ऑफ चार्ज्ड कंडक्टर. इफ सिग्मा इज अ सरफेस चार्ज डेंसिटी एंड चार्ज कैरिड बाय एलिमेंट. अब सिग्मा क्या है हमारा? सरफेस चार्ज डेंसिटी है. तो सरफेस चार्ज डेंसिटी बराबर चार्ज पर यूनिट एरिया रहता है. तो चार्ज कितना आएगा? dq बराबर सिग्मा इंटू ds. तो इस ds पे चार्ज आएगा dq. अब हमें दो पॉइंट कंसिडर करना है, एक आउटसाइड में यहाँ पे P1 और एक इनसाइड में P2. अब हमें एक बात पता है कि इलेक्ट्रिक फील्ड इंटेंसिटी आउटसाइड पॉइंट की क्या रहती है? E इक्वल टू सिग्मा बाई एप्सिलॉन नॉट. याद ही रखना है. अब ये पॉजिटिव चार्ज है तो डायरेक्शन ऑफ इंटेंसिटी नॉर्मली आउटवर्ड रहेगा. अब हमें फोर्स का इक्वेशन प्रूव करना है, तो दो इलेक्ट्रिक फील्ड कंसिडर करेंगे हम. एक E1 इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू द चार्ज ऑन एरिया ds. अब एरिया ds पे जितना भी चार्ज है वो E1 फील्ड प्रोड्यूस कर रहा है. और E2 इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू रिमेनिंग चार्ज ऑन द बॉडी. Suppose we put the positive charge at P1, test charge. Then due to the charge on area ds, this positive charge is moved outward. And again due to the remaining charge produce the intensity at point P1 is. Therefore, net electric field E outside is a summation of E1 and E2. But what happens the inside? We know that electric field inside any conductor, any charged conductor, when it conduct is in rest, then electric field inside the conductor is 0. Therefore, direction of E1 and E2 must be opposite for obtaining net field 0. This whole charge produces the electric field along this direction. Consider along this direction, and therefore due to the charge on area, electric field is along this direction. Now this E1 and E2 must be opposite for maintaining net field equal to 0. E is a summation of E1 plus E2. Therefore E1 plus E2 equal to sigma by epsilon naught. But inside point net field is 0. Therefore E2 minus E1 equal to 0. Then we get E1 equal to E2. Now above equation 3 becomes put E1 as E2. Therefore we get 2E2 बराबर sigma by epsilon 0. Therefore E2 equal to sigma by 2 epsilon naught. Again, what is E2? Electric field intensity due to remaining charge on the body. Now, what force act on the body? We know that famous equation E equal to F by Q. Therefore, F equal to Q by E. Therefore, force act on area ds is represented as df. Then, on this area ds, electric field is intensity due to remaining charge E2. Therefore, we know that force act on any small surface due to electric field of other, not due to its own charge. Therefore, force act on area ds is df is E2, F equal to again QE. Then Q is a charge on area ds, dq, sigma ds, and E, electric field, is due to remaining charge. And electric field due to remaining charge is sigma by 2 epsilon naught. Therefore, small force df act on the area ds is sigma square by 2 epsilon 0 into df. Very famous equation. But we calculate the force per unit area. Then we obtain df by ds equal to sigma square by 2 epsilon 0. In problems, we must remember one formula. Force act on the area of charge conductor is F equal to sigma square by 2 epsilon 0 into given area. But electric field intensity due to the charge conductor just outside E equal to, or on the surface, E equal to sigma by epsilon 0. Therefore, sigma equal to epsilon 0. When we put sigma equal to epsilon 0, E, we get F equal to 1 by 2 epsilon 0 square E square into area. Remember, these two equations represent the force act on any charged conductor. One is easy formula, 1 by 2 epsilon 0 E square into area. Another is sigma square by 2 epsilon 0. But force per unit area. What is a force per unit area? Then force per unit area is nothing but sigma square by 2 epsilon 0, or famous 1 by 2 epsilon 0 E square. Now, next article is energy density. What is meant by energy density? Energy stored per unit volume in a charged conductor. Now, due to the force act on area ds, due to the force act on the area ds, suppose this area ds is displaced by distance dx, very small or infinitesimal displacement. Due to force act on the area ds, sigma square, force is a sigma square by 2 epsilon 0 into ds. This force act on this area ds. And due to this repulsive force act on area ds, it moves by distance dx. Then, under the action of force of the element ds moves outward through the distance dx. Then some work is done. Work done is nothing but force into displacement. Force is a df, displacement is dx. We get work done as sigma square by 2 epsilon 0 ds into dx. But ds into dx is nothing but volume, change in volume. Therefore, du equal to sigma square by 2 epsilon 0 into dv. This equation gives the energy stored in volume dv in a charged conductor. But this work done is stored as electric potential energy, already explained that. Then energy per unit volume or energy density is, then energy density is energy per unit volume. Now volume of this small part is ds into dx equal to dv, area into length. Therefore, du by dv, then dv cancel, we get energy density as sigma square by 2 epsilon 0. If we put sigma as epsilon 0 e, then we get again same equation as in case of force per unit area. For same equation for energy density, energy per unit area, energy per unit volume is again sigma square by 2 epsilon 0 1 by 2 epsilon 0 e square. Again, dimensions of force per unit area and energy per unit volume is same. Force is Newton per meter square, energy is Newton meter, volume is meter cube. Then again we get Newton per meter square. Therefore, dimensionally is also correct. Force, mechanical force is directly proportional to sigma square. Sigma square. Therefore, sigma is maybe positive or negative. Square is always positive. Therefore, mechanical force does not depend on the polarity of charge. Also, here mechanical force is a repulsive force, nothing but. Therefore, is always away from conductor, away from the conductor. देखो यहाँ एक प्रॉब्लम दिया है. What is the energy stored per unit volume, मतलब energy density in vacuum where the intensity of electric field is 10 to the power 4 volt per meter. We know that the formula of energy density is 1 by 2 epsilon 0 e square in vacuum. For medium we multiply epsilon 0 by k, but now in this case vacuum 1 by 2 epsilon 0 is 8585 into 8.85 into 10 to the power minus 12. E square is 10 to the power 4 into 10 to the power 4. Then 8.85 by 2 is 4.425. Then minus 12 plus 8. Therefore, 4.425 into 10 is the unit of energy density, energy per unit volume, joule per meter cube. Now, a metal plate of surface area. Now, metal plate has a 2 surface area, right? Metal plate of surface area 2 meter square is charged. मतलब this charge, मतलब क्या है देखो, this charge is on one side of the conductor 8.85 microcoulomb. This microcoulomb is out of the square root. Then what is the mechanical force acting on the plate? Formula of mechanical force is sigma square by 2 epsilon 0 into given area E. Now first calculate the sigma. Then sigma is nothing but Q by A, charge per unit area. Charge is root 8.85 by area of surface area is 2. Therefore, sigma square is 8.85 microcoulomb, means minus 12 by 4. Then put in above equation 8.85 into minus 12 by 4 into 2, epsilon 0 is 8585 minus 12 into area is nothing but 2.